Okay, so in this video, I'm going to go through section 1.8, which is measures of variability. And then we're going to talk about standard deviation first, just because that was more new than the rest and a little more complicated. So standard deviation measures how spread out the data is from the mean. So standard deviation and mean always go together. I have two data sets shown here. So in the first one, the standard deviation is 1.59. And so you can see that the dotted line that represents the mean, all the dots are pretty close to that value versus the one with the standard deviation of 2.79. The values are further away from the mean that is represented by that dotted line. And so visually, that's what a larger versus smaller standard deviation. And so if we're looking at the two distributions here, the standard deviation for A compared to the standard deviation for B, if we look at these values for A, it's more spread out, right? It's a wider range of values versus for B, it's a smaller range of values. It only goes from 4 to 9 compared to going from 0 to 10. Okay, so that visualization of the values are closer to the mean means that has a smaller standard deviation. So that means that the standard deviation of A is bigger than the standard deviation of B. Okay, we aren't going to calculate those standard deviations, but if we were, the standard deviation of A would be larger than the standard deviation of B because the values from A look more spread out than the values for B, spread out from the mean. Okay, and again, these were the means in these graphics. So in this, we calculated sample standard deviation because we were working with samples of data. And so the formula for sample standard deviation was that S equals the sum of the difference of each data point minus the mean of the data squared divided by the number of data values minus 1. So if we're looking at these things, S is the sample standard deviation. The uppercase sigma represents the sum of. And then X bar, remember, is our sample mean. And I need to add a different highlighter color. Let's do green. And N is the number of data points in the sample. And so we use a table to identify standard deviation just to kind of keep our work organized. We will start with the mean of the data set. I'm just going to add the data into the table. So remember, this X sub I is just saying each term. So it's X sub 1, X sub 2, X sub 3, so on. So I'm just going to input the data into that table. So our data was 9, 2, 5, 4, 12, 8, and 8. And so the first thing that I have to do to find the mean is I have to find the sum of that data. So if I add those data values up, I get 48. So that means the mean is 48 divided by the number of data points here. So if I look at this, how many numbers are here? There are 8. So that's our N. Okay, so N is 8. Oops. So if I divide 48 by 8, that tells us that X bar is 6. Okay. And so what I'm going to do here is, let me change that color, is I'm going to take that 6 and I'm going to subtract it from each data value. So I'm going to do 9 minus 6. So that gives me a 3. 2 minus 6 gives me negative 4. 5 minus 6 gives me negative 1. 4 minus 6 gives me negative 2. 12 minus 6 gives me 6. 8 minus 6 gives me 2. And 8 minus 6 again gives me another 2. Okay. So once I found the difference between the data point and the mean, I want to take these numbers and I want to square them. Remember that when I'm squaring these, I should be putting them in parentheses in my calculator, meaning that all of my answers should be positive. So when I square 3, I get 9. When I square -4, I get 16. When I square -1, I get 1. When I square -2, I get 4. When I square 6, I get 36. Squaring 2 gives me 4 and 4 again, because that's the same data value. Okay. So I've found each difference of the data minus the mean squared. Okay. So the next step, what I have to do is find the sum of all of that. So let me change a color here. Let's do. So if I find the sum here, so if I add these all up, I get 74. Okay, so now using our formula, so S equals the square root of the sum of all the squares, so the sum of this column, which is 74, divided by not n, but n minus 1. Okay, so n minus 1 is 7. So the standard deviation of our sample is going to be the square root of 74 divided by 7, which if we calculate is about 3.25. Okay, so S is about 3.25. Remember that means that the data varies by an average of about 3.25 from the mean of 6. Okay, so that's what standard deviation means, is that the data in general varies by an average of that value from the mean. The last thing that I was going to go over with the same data is the other two measures of variability, which are the range and IQR. So we've been using range a lot in problems where we have like a histogram. And so in this one, we have the data, so we're going to use it to find both the range and the interquartile range. So to do that, remember that we want the data to be in order. So if I'm looking at this, I've got 2, then 4, then 5, then 2 8s, then a 9, and a 12. Okay, so that's my data set. Remember that in order to find the range, I'm going to do the max minus the min. So my minimum is 2 and my maximum is 12. So that means my range is 10. For IQR, I have to find the quartiles. So for IQR, I'm doing quartile 3 minus quartile 1. Okay, so in order to find the quartiles, I have to first find the median. So if I'm looking at this data set, since there are 7 values, that means that the median is 8. Then from the median, I have to look at the other part of the data. So remember, for quartile 1, I'm looking at these data values. For quartile 2, I'm looking at these data values. When I have this odd number, the median is not part of my data set to find the quartiles. So this one's nice because it's another odd number. And so that means that quartile 1 is 4 and quartile 3 is 9. So that means that the interquartile range is 9 minus 4 or 5. So those are the 3 different measures of variability that we will talk about. Again, standard deviation is the more complicated one, and that table is most helpful for calculating the value.